Okay, in 11.2 we cover the area of circles and sectors. So first thing we're going to talk about is circles. You should be very familiar with this formula. The area of a circle is pi r squared. So some things that you need to watch out for when you're looking at this means that's the diameter, which means we would need to cut that in half to find r equals 85. So area equals pi 85 squared. Only square the 85. So your area would equal 7225 pi. That would be the exact answer, units squared. Or you could say an approximate 22,686.5 units squared. Okay, so always know what you're looking at. And this is the circumference of the blue circle only. Does not include this outer portion. Okay, so always watch where your diameter starts and ends. Okay? All right, this is just telling you what concentric circles are. They all have the same center, and that's just an important thing to know in future problems. Okay, so probabilities found by calculating a ratio of two lengths, areas, or volumes are called geometric probabilities. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? So first notice that 10 points, this little circle, has a radius of 3. 0 points would be a calculation of the whole thing. So 0 points would be you got it outside this whole circle. So you'd have to do a donut problem where you'd take this minus the largest circle. Okay, so we're going to do one at a time. So the probability of 10 points is the ratio of the smallest circle, which is a radius of 3, so 3 squared pi over the area of the entire board. So look here, this is 3 plus 3 plus 3 is 9, which means that the whole side is 18, so the probability of the whole thing would be 18 by 18. Okay, so 18 squared. So now we're going to get 9 pi over 324, which simplifies to pi over 36, or approximately 0.0873. Now, the probability of getting 0 points would be the area outside the largest circle. So the first thing we have to do is go 18 squared minus, and then that square has a radius of 9, so it's 81 pi, that's our area of our biggest circle, over the whole thing. So that'd be 324 minus 81 pi, which I already wrote, dang it, 81 pi over 324. And so that would be 4 minus pi over 4. We factored out the 81, and that gives us approximately 0.215, or 20. This is 21.5%, and this is 8.7%. So it is much more likely that you will get 0 points, which is pretty sad. All right? Okay, so let's try another one. You throw a dart at the board shown. Your dart is equally likely to hit any point inside the square board. What is the probability that your dart lands in one of the two yellow regions in the smaller circle? So that's here or here. So we're going to go P of landing on the smaller regions. And I would say that is 1/2 of pi times 2 squared. Okay, so that's the inner circle, but only half of it. Okay, so that'd be 1/2 of 4 pi, so it'd be 2 pi. That's just the probability of the top, and then out of the whole would be 100. So that we would simplify that to pi over 50, which is approximately 0.063. Oh, and I got the denominator by going 2 plus 3 is 5, plus 5 is 10. So 10 squared is 100. Sorry, I forgot to say that. And so that is 6.3% chance of getting it in one of those two yellow sections. Okay. Now we're going to talk about sectors of a circle. And the easiest way to remember a sector is a piece of pizza, a piece of pie, a piece of the total area. Okay? So again, we're going to be using that central angle. So the area of a sector is a fractional part of the whole area. So if you look at this example, you're going to take the sector and you're going to multiply. So here's the central angle, or the measure of the arc, over the whole times the area Okay? So I don't usually use this one, but I do if I'm having to solve it for a different part. But when I'm just being given the area, then I can do it this way. So you have to realize what you can do. You can either set up a ratio, a proportion, or you can just multiply the degree by the area. Okay? The portion of the degree. So let's do a few examples. Okay, so in this next problem, we're going to be finding the area of the sector. Now notice they want you to find the area of both sectors. They gave us some information here at the beginning. We already calculated that this was 70 degrees because we know that this is the central arc. And so this would be 360 minus 70, which is 290. So that'll come in handy as we're working these problems out. So the first one we're going to do is we're going to find the sector of the area of the small sector. So that would be the measure of UV, so that's 70 over 360, which we're going to simplify and say 7 over 36 times our area. So that's pi r squared. Our radius is 8, so that's 64 pi. So we could simplify that a little bit, and we would get 7 over 9 times 16 pi, because we cross-canceled there. And that would calculate out to 112 over 9 pi inches squared. Okay, so that is your exact answer, if you're asked for the exact answer. If they want an estimate, that will be about 39.10 inches squared. Okay, now if we're going to calculate the area of the larger sector, we're going to use 290 over 360. We're going to simplify that to 29 over 36, sorry. And multiply that times 64 pi. That's pi r squared. Again, we're going to simplify, so we get 29 over 9 times 16 pi. And then we're going to multiply that out. We get 464 over 9 pi. Now, you could take the time to make that into a proper fraction. You don't have to. This would be fine with me. So that would be inches squared. That, again, is your exact answer. If you need the estimated answer for a word problem or such, then it would be approximately 161.97. And there are your answers to check. Okay, let's try another one. So they want you to find the indicated measure of the area of the red sector and the area of the blue sector. So I'm going to do the red sector first, and we're going to go 120 over 360, and I want you to do a lot of these examples to make sure you're good at this. That's 1/3, so we're going to go 1/3 times pi, and our r is 14, so 14 squared. So 14 squared is 196 over 3. Pi is our final answer. Okay? And that actual answer would be about 205.25 feet squared. That's your estimated answer. Okay? This is your exact answer. Okay, now to find the blue one, might as well switch to blue so we don't get mixed up. So that would be 240, because 360 minus 120 is 240 over 360. Simplify that, it becomes 2/3. We already know that 14 squared is 196, so we're going to go 2/3 times 196 pi equals 392 over 3 pi. And I'd leave it like this because we really don't need to worry about messing up. Okay, don't forget you'd always put your units. And if you wanted the estimated answer, it would be about 410.5 feet squared. Alrighty, so keep practicing, keep doing what you need to do. Alright, here's one, whoops, and there's the answers. So those were the estimated answers. Okay, so here is find the area of the circle. So this one, they gave us the area of the sector. Okay, so we're going to set that up. We're going to, the area of the sector is 35. And that equals 40 over 360, that's our portion of the circle, times the area of circle V. So we're going to cancel that. We're going to get 35 equals 1/9 times area of circle V. So we're going to multiply both sides times 9. And we get 315 equals the area of circle V. And that would be 315 meters squared. All right, so that's an easy way to go about that. Okay, now we're going to do a couple of compositions. We're going to find the area of a region. So a rectangular wall has an entrance cut into it. You want to paint the wall. So we're painting the blue portion. Okay, so be very careful. And to the nearest square foot, what is the area of the region you need to paint? So we're going to take the area of the whole wall, and that's the area of the rectangle, minus the area of this. Okay, so we're going to subtract that. So we've got a lot of little things to do. So first thing we're going to do is find the area of the rectangle, and that's easy because that's 36 times 10 plus 16 is 26. So that equals 936. Okay, so that is the area of that. And I'm going to change colors just to keep everything straight. So now we're going to find minus, and we're going to calculate the rest of this. So for this rectangle, we have 16 times 16. So that's 16 squared plus, so that's the area of that. And then we've got to figure this out. So this is a semicircle. So it's 1/2 of the circle, right? 180 over 360 times pi r squared. And our radius is 64. So 64 pi. Okay, so we've got to do a couple more calculations. Let's go over here and do that. So we've got 256 plus, and that would be 32 pi. And so 256 plus 32 times pi is approximately 100.48. And so then we would add those together, and we would get minus 356.48. Okay? And so our answer is approximately 579.47 feet squared. Okay, that is the area that we'll be painting. So make sure you think these through when you're doing this kind of problem. Okay? All right. Here's the next one. Find the area of the figure. So remember, 7 is the diameter. So when we're calculating the circle, the radius is 3.5. Okay, so we're going to do the area of the semicircle. And that would be 1/2 times pi. R is 3.5 squared. So 1/2 times 12.25 pi. And so that is approximately, with the pi and everything, approximately 19.2325. Now we're going to have the area of the triangle, and that is 1/2 times 7 times 7, times 7, and that is 24.5. So now we're going to add those together, 24.5 plus 19.2325, and that is approximately 43.7 meters squared. And that would be your final answer for that one. Okay, the last thing we're going to talk about, and there we go, is the segment of a circle. And this is a segment, okay? So how I would describe that, the crust of the pizza, whatever you want to, however you want to describe it, that's how you could describe it. So to find the segment of a circle, we first find the area of the sector. So that's this. Okay, so find the area of the sector. And then we're going to minus the triangle. And that will give us the area of the segment. So this is the most common way to do it. So we're going to figure out our sector. So 90 over 360 equals 1/4. So times pi, r squared, so r is 8, so 64 pi. And then we're going to cross cancel, so we get 16 pi. Now, when we subtract this triangle, it's not going to have a pi, so we're going to have to calculate that out. So, but first we're going to go ahead and do the triangle. The triangle is 1/2 times 8 times 8. And so that is 32. And so now we're going to do 50.24 minus 32, and we get approximately 18.24 is the measure of our segment. So our segments are almost always going to be estimated, because I don't want you to leave pi in a formula there. Okay? All right, we got one. Okay, so we're going to do this one in the terms of pi, and we're going to also do the estimated answer. So the length of the radius is 10. Okay, so the first thing I'm going to find is the area of the whole circle, and that is pi r squared, so that would be 100 pi. Okay, now if you just look at this area, this is 3/4 of it, because this is 1/4, right? So 3/4 of the circle, 3/4 of the circle is 75 pi. And then we would add the area of the triangle. So add the area of the triangle is 1/2 base times height. So that's 50. So this is the answer in pi form. Okay? So you could just go ahead and quickly calculate that out. Now, some of you might have thought about finding just the sector and then getting the segment and subtracting that from 100. So let's see if that's actually what we get. So we know that the sector is 1/4 times 100 pi. So that would be 25 pi, which makes sense. And then minus the triangle, so that would be 50. So then you would calculate 78.5 minus 50 equals 28.5. And so that would be the area of that would be the area of the whole, that would be just the area of the segment. And so then you would go 314, which is pi times 100, minus 28.5, and that comes to 285.5 inches squared. So that's calculating it this way. And now if you go back and you multiply 75 times pi, plus 50, you would get that same answer. So there's both different ways to go about it. You could do it either way. So you can figure out what you want to do, but